Hello students. So in this video we are going to discuss some problems based on the relative maxima and minima of the function of two or more variables. So in our last video we have discussed the concept that what is the process we need to follow to check or to find out the maxima or the relative maxima and minima of the function of two or more variables. So So in this case, we directly going to discuss some problems based on this particular criteria. Right. Let me firstly recall that what are the criteria I'm going to follow to check the relative maximum and minimum of the function. So in this case, firstly, we are going to consider the problem based on a function of two variables. So the criteria is we are going to firstly calculate first order derivative with respect to the variables, with respect to x and with respect to y, and then we'll put it equal to 0. And by solving these two system of equation, we'll try to find out the value of x and y. So if this is a point AB, then based on that, we'll try to calculate the second order derivative with respect to x at the point AB. We name it as r. We are going to calculate second order derivative with respect to y at the point AB. We name it as t. And second order derivative with respect to x, y at the point AB, and we name it as s. And then to check the condition of extreme point, we firstly check the condition RT minus SQ. If it is greater than 0, then we have a two possibility. Either R and T, both of them are positive, or R and T, both of them are negative. If both of them are positive, then we say that the point AB is the point of minima, and here in this case we say that it is a point of maxima. And if they are of opposite sign, means if RT minus SQ is less than 0, then we say that AB is the point of neither maxima nor minima. Neither maxima nor minima. Right? So let us start with this procedure. So the first problem is here we are given function f of x y is equal to square root of means a square minus x square minus y square whole power 1 by 2. So the first step is we need to find out its partial derivative with respect to x. So we are going to use the derivative of the composition of the function chain rule. We have already discussed that if z is a function of x and y, and x and y and sorry z is a function of single variable, say u, this is case number 1, and u is the function of x and y, then the derivative of z with respect to x is f dash u into derivative of u with respect to x. Okay, so here this is our u, which basically depend upon x and y, and your function is square root of x. So what is the derivative of square root of x? If f of x is square root of x, then f dash x is 1 by 2 times square root of x. So we are using this derivative formula. So this derivative is 1 by 2 a square minus x square minus y square raised to the power minus 1 by 2 into curly by curly x of a square minus x square minus y square. And when we differentiate with respect to x, we are keeping y and z as a constant. So a is already constant, derivative is 0, derivative of y square is also 0. So this is 1 by 2 square root of a square minus x square minus y square as it is, and its derivative is minus of 2 times x. So this 2 and 2 get cancelled out. So basically this is minus x upon square root of a square minus x square minus y square. So this is the value of curly f upon curly x. Now we are going to calculate curly f upon curly y. So because you can see here, if I interchange x with y, then again your function remains same, a square minus y square minus x square. So what is curly f upon curly y? Simply interchange x with y. So this is minus y upon square root of a square minus x square minus y square. Otherwise we can use the same formula for calculating curly z upon curly y. This will equal to f dash u into curly g upon curly y, right? So in that case, again, firstly, power rule is same. So in that case, instead of x, we can differentiate with respect to y, and the derivative y square is minus 2y. So we can get this one, right? So the first step is for the extreme point. For the stationary point, the condition is this first order derivative should be 0. So for extreme point, we are using the condition curly f upon curly x equal to 0 and curly f upon curly y equal to 0. So if we put it equal to 0, means minus x upon square root of a square minus x square minus y square equal to 0, and here minus y upon square root of a square minus x square minus y square equal to 0. Okay, so clearly, so from this particular part, we'll get point x equal to 0 and y equal to 0. So this case, we get only one point, x equal to 0 and y equal to 0. So what is the point AB? So it means that the extreme, the point, stationary point is, so we'll get the stationary point as xy is equal to 0, 0. So it is the extreme point, means either it is the point of maxima or minima if it satisfies the condition RT minus SK greater than 0, right? It is the point, extreme point if this is positive. So it means that firstly we need to calculate second order derivative with respect to x. So curly square f upon curly x square means curly by curly x of curly f upon curly x, which is curly by curly x of minus x upon a square minus x square minus y square raised to the power 1 by 2. So now this time we are going to use the quotient rule, that d by dx of fx upon gx. This is g of x square, g of x time derivative of fx minus fx derivative of gx. So this is the quotient rule. So this is equal to negative sign taken outside, a square minus x square minus y square raised to the power 1 by 2. So this is a square minus x square minus y square into curly by curly x of x minus x time curly by curly x of a square minus x square minus y square raised to power 1 by 2. This is minus, it's a scale. So it will be a square minus x square minus y square as it is. So in the numerator, a square minus x square minus y square, derivative of x is 1 minus x. And what about this? This is the derivative we have already considered here, curly f upon curly x, right? Its derivative is minus x upon square root of, so this is minus x upon a square minus x square minus y square raised to the power 1 by 2, right? So if we take the LCM, so first step is so here this negative sign get cancelled out with this negative sign. So we can get here curly square f upon curly x square. This is minus sign common. So a square minus x square minus y square. And if we take this LCM, so a square minus x square minus y square raised to the power 1 by 2. So when we multiply it with this, here the power is 1 by 2. So 1 by 2 into 1 by 2, it become 1. So a square minus x square minus y square plus x square. So you can see here this x square and x square get cancelled out. So with this negative sign, its value comes out to be minus of a square minus y square on a square minus x square minus y square raised to the power 3 by 2, right? So similarly, we can get curly square f upon curly y square also, because like I told you that it is a symmetric function. If I interchange x with y, again your function is same. So second order derivative is also obtained by interchanging x with y, but let us try to calculate this. This is minus of curly by curly y of curly f upon curly y. This is sorry, minus y upon a square minus x square minus y square raised to the power 1 by 2. So this negative sign taken outside. This is a square minus x square minus y square. Here a square minus x square minus y square raised to the power 1 by 2 into curly by curly y of y minus y time curly by curly y of a square minus x square minus y square raised to the power 1 by 2. So again, this derivative is same as curly f upon curly y, whose value is minus y upon square root of a square minus x square upon y square. So if I substitute this value here, so this is minus of a square minus x square minus y square raised to the power 1 by 2 into derivative is 1 minus y time minus y upon a square minus x square minus y square raised to the power 1 by 2 whole divided by a square minus x square minus y square. So if I take this LCM, this will be minus this 1 by 2 power 1 by 2 become 1 a square minus x square minus y square. This negative and negative become positive plus y square upon a square minus x square minus y square. 1 and 1 by 2 become 3 by 2. So this time here y square and y square get cancelled out. So its value is minus of a square minus x square upon a square minus x square minus y square raised to the power 3 by 2. So you can see here, if I interchange x with y, you can get the same value, right? So now we need to calculate the second order derivative with respect to xy. So curly square f upon curly x curly y. This is curly by curly x of curly f upon curly y. So this is curly by curly x of minus y upon a square minus x square minus y square raised to the power 1 by 2. So when we differentiate it with respect to x, then this y is constant, this term is constant. So we just simply apply here power rule. So minus 1 by 2 a square minus x square minus y square raised to the power minus 1 by 2 minus 1 into curly by curly x of a square minus x square minus y square. So this is equal to y by 2 a square minus x square minus y square raised to the power 3 by 2 in the denominator, and its derivative is minus 2x. So 2 and 2 get cancelled out, so its value is minus xy upon a square minus x square minus y square raised to the power 3 by 2. So this is the value of curly square f upon curly x curly y. Now we are going to calculate r, t and s. So what is r? R is curly square f upon curly x square at the point AB. AB is 0 0. So this is limit xy tends to 0 0 because it's a polynomial function, partial derivatives are continuous. So we can apply a limit curly square f upon curly x square. So this is limit xy tends to 0 0. So curly square f upon curly x square, its value comes out to be minus of, if I adjust this negative sign, this is y square minus a square, right? So this is minus of a square minus y square upon a square minus x square minus y square raised to the power 3 by 2. Now because a function is defined at the point 0 0, if I substitute its value here, so on substituting this limit, it is minus of a square and a square raised to the power 3 by 2. So this is minus a square, and here 2 power get cancelled out, a cube. This is minus 1 upon a. And because it is given in the question that a is greater than 0, if a is greater than 0, then this should be less than 0. So what do we get here? R is less than 0. Similarly, what about t? Curly square f upon curly y square at the point 0 0. This is limit xy tends to 0 0. Curly square f upon curly y square. So this is limit xy tends to 0 0. This is minus of a square minus x square upon a square minus x square minus y square raised to power 3 by 2. So this is minus a square minus 0, a square minus 0 minus 0. So this is minus a square upon a cube. So again minus 1 upon a, which is again less than 0, which means t is also less than 0. And what about s? If we calculate s, here s is curly square f upon curly x curly y at the point 0 0. So this is limit xy tends to 0 0 curly f curly square f upon curly x curly y. This is limit xy tends to 0 0. It is minus of xy, value is minus of xy upon a square minus x square minus y square raised to the power 3 by 2. So if I put x by 0, then its value is 0. So s is 0. So what do we get from here? S is 0. R is minus 1 upon a. T is minus 1 upon a. So what about RT minus S square? Minus 1 upon a minus 1 upon a minus 0, 1 upon a square. And we know the square of a number is always positive. So RT minus S square is positive. R and T is less than 0. It means that 0 0 is the point of relative maxima. What is the condition of maxima? If the second order derivative, both of them are negative and RT minus S square is positive, then this is the point of maximum. Okay. So what do we conclude here? That a 0 0 is the point of maximum. And what is the maximum value? Maximum value of the function is f of 0 0. This is square root of a square minus 0 minus 0 is square root of a square. And this is a because a is already positive. So this is the maximum value of the function. Okay. So this is the first problem we have discussed. Now consider the another problem. This time we are given a function here x square plus xy plus y square 1 upon x plus 1 upon y. Let us try this part. So the first step is we need to find out the extreme point. So for that we calculate curly f upon curly x, derivative of x square 2x, derivative of x y square 0 minus 1 upon x square. Simply using derivative of x power n is n times x power n minus 1. And derivative of ax is equal to a times what? Derivative a of f of x. You can say derivative of a times f of x is equal to a times derivative of fx. Okay, linearity property. So its value is 2x plus y minus 1 upon x square. Now curly f upon curly y. Derivative with respect to y is 0, x 2y 0 minus 1 upon y square. That is x plus 2y minus 1 upon y square. Because derivative of x square with respect to y is 0, x is constant, derivative of y is 1, derivative of y square is 2y, derivative 1 upon x is 0, derivative 1 upon y is minus 1 upon y square. Okay, so for the stationary point, for the extreme point, the condition is we put curly f upon curly x equal to 0, curly f upon curly y is equal to 0. So when we put them equal to 0, so curly f upon curly x equal to 0 implies 2x plus y plus 1 minus 1 upon x square equal to 0, and curly f upon curly y equal to 0 means x plus 2y minus 1 upon y square equal to 0. So basically, it will gives us this is number one, this is number two. So the first equation is 2x plus y minus 1 upon x square equal to 0, or I can write it as 2x plus y into x square equal to 1 means 2x cube plus x square y equal to 1. Similarly, second equation will be x plus 2y minus 1 upon y square equal to 0 means y square into x plus 2y equal to 1 means xy square plus 2y cube equal to 1. Now we have a two system of equations with two unknown, but these two equations are non-linear. Okay, so this is not the easy job to find out the value of x and y. So what can we do? So because both of them are equal to 1, so it means that say this is equation number 3 and 4. So because both of them are equal to 1, it means both of them are equal, means 2x cube plus x square y, or you can say I am subtracting 3 minus 4. So minus x y square plus 2y cube equal to 0. So I have simply done 3 minus 4. So combining 2x cube minus 2y cube, and here x square y minus xy square equal to 0. So here 2 common, and this is a cube minus b cube. So let me consider the another slide here. I can consider 2 times x cube minus y cube, and here xy is common, x minus y, xy is common, x minus y, and here also I'm using a cube minus b cube, a minus b, a square plus ab plus b square, or x minus y is common. So this is 2x square plus 2xy plus 2y square plus xy equal to 0, or x minus y 2x square plus 3xy plus 2y square equal to 0. So because we are expecting real root, so it is not possible to get a real root from this one. So the only possibility we are getting here x equal to y. And if we substitute this value in equation number 1, so if from equation number 1, equation number 1 is 2x plus y equal to 1 upon x square. So if x equal to y means 2x plus x equal to 1 upon x square is 3x into x square equal to 1. It means that x cube equal to 1 upon 3, or x equal to cube root of 1 upon 3. And because x equal to y means that y is also equal to 1 upon cube root of 3. So what therefore the point xy is equal to 1 upon cube root of 3, 1 upon cube root of 3. This is the extreme point, right? Because a cube equal to b cube having only one real root, that is a equal to b. Now we need to check that either this is the extreme point or not. So for that we are going to calculate second order derivative. So second order derivative with respect to x. Curly square f upon curly x square means curly by curly x of curly f upon curly x. This is curly by curly x of 2x plus y minus 1 upon x square. Derivative of 2x is 2, derivative y is 0, derivative 1 upon x square is 2 upon x cube. So it is 2 plus 2 upon x cube. Similarly, curly square f upon curly y square, curly by curly y of curly f upon curly y by curly y of x plus 2y minus 1 upon y square. X plus 2y minus 1 upon y square. So its derivative of x is 0, derivative of y is 2 upon y cube. So it is 2 plus 2 upon y cube. And what about curly square f upon curly x curly y? This is curly by curly x of curly f upon curly y. This is curly by curly x of x plus 2y minus 1 upon y square. Its derivative is 1, which is constant. So now I need to calculate RT minus S square at the point. So R means curly square f upon curly x square at the point cube root of 1 by 3 and 1 by 3. So limit xy approaches to cube root of 1 by 3 and 1 by 3. Curly square f upon curly x square, that is xy approaches to 1 upon cube root of 3, 1 upon cube root of 3, 2 plus 2 upon x cube. So x is 1 upon cube root of 3. So this is 2 plus 2 times 3, because its cube is 3 only, 1 upon 3. So it's reciprocal. So 3 to the 6 plus 2, 8. Similarly, t curly square f upon curly y square. This is limit xy tends to 1 upon cube root of 3, 1 upon cube root of 3. This is 2 plus 2 upon y cube. Same function. So 2 plus 2 into 3, its also value is 8. Positive, positive. So what about RT minus S square? Because R is 8, T is also 8, S is 1, which is already constant. S is already 1, right? So it means the value of S curly square f upon curly x curly y at the point 1 upon cube root of 3, its value is 1 only because it is constant. So 64 minus 1 is 63. It is already positive. R is positive, T is positive, RT minus S square is positive. It means that 1 by cube root of 3, 1 by cube root of 3 is the point of relative minimum, right? So if this is a point of relative minimum, what is the minimum value? So basically x and y are same. So if I replace x with y, then this is x square, x square, x square, 1 by x, 1 by x. This is 3x square plus 2 by x. And if x is 1 by root 3, cube root of 3, then this is 3 times 1 upon cube root of 3 plus 2 upon cube root of 3. So this is basically 5 times 5 upon 3 times cube root of 3. What is the minimum value? F of 1 upon cube root of 3, 1 upon cube root of 3 is 5 times. Reciprocal means it comes in the numerator. Okay, it's a 2 times cube root of 3. Wait. So it is 2 times cube root of 3, and this is 3 raised to power 1 minus 1 by 3. This is 3 raised to power 2 by 3. It is 3 raised to power 2 by 3 plus 2 times 3 raised to power 1 by 3. So 3 times 3 raised 3 raised to the power 2 by 3 plus 2 times 3 raised to the power 1 by 3. This is the answer. Okay. Okay, so the process is basically how do we find out the relative maxima and minima of the function? So the first step is calculate first order derivative with respect to all the variable, put them equal to 0, and then find out the value of x and y, and then find out second order derivative and check the nature of the function at the point a b. If r and t both of them are positive, rt minus s square is positive, then it is a condition of minima. And if r and t both of them are negative and rt minus s square is positive, it is a condition of maximum, right? Okay, now we are going to discuss the problem based on the function of three variables, right? Okay, so we have already discussed the case that if we have a function of three variables, then what is the criteria? So the first step is we are going to find out its first order derivative with respect to all the three variables. What is curly f upon curly x? It is 18z minus 6y minus 18x, 0 and 0. So 18z minus 6y minus 18x. Now we calculate curly f upon curly y. It is 0 minus 6x minus 0 minus 4y minus 0. So it is minus 6x minus 4y. I will calculate curly f upon curly z. It is 18x minus 0 minus 0 minus 0 minus 108z. That is 18x minus 108z. So now for the extreme point, we are going to apply the condition that curly f upon curly x equal to 0, curly f upon curly y equal to 0, curly f upon curly z equal to 0. So it will give us 18z minus 6y minus 18x equal to 0. This is number 1. The first equation gives us this one. This is second equation. So second equation will give us minus 6x minus 4y equal to 0. So we can get minus 4y equal to 6x. So the value of y is minus 3 by 2x. And from third equation we can get 18x minus 108z equal to 0. So 108z equal to 18x. So z equal to 18 by 108. X means 1 by 6x. So y in term of x, z in term of x. So if we substitute it in equation number 1, so we get 18z minus 6y and minus 18x equal to 0. So this is 3x plus 9x minus 18x equal to 0 means this is 12 minus 18 minus 6x equal to 0. It will give us x equal to 0. If x equal to 0, we get y equal to 0 and z equal to 0. What do we get from here? So we get the point as x equal to 0, y equal to 0. So the point is 0, 0, 0. Now we need to find out second order derivative. So the second order derivative curly square f upon curly x square. Second order derivative with respect to x is curly by curly x of 18z minus 6y, 18z minus 6y minus 18x. So this is minus 18. Curly square f upon curly y square. So second order derivative with respect to y. So curly by curly y of minus 6x minus 4y. minus 6x minus 4y, this is minus 4. And what about curly square f upon curly z square? So curly by curly z of curly f upon curly z. Curly by curly z of 18x minus 108z. That is minus 108. So you can see all third order derivatives, second order derivatives are negative with respect to the main variable x, y, z. Now we are going to calculate mixed derivative curly x curly y with respect to y. So curly f upon curly y is minus 6x minus 4y. Its value is minus 6. Curly square f upon curly x curly z. Curly by curly x of 18x minus 108z is 18. And curly square f upon curly y curly z. Curly by curly y of 18x minus 108z is 0. So now I am going to construct the matrix A, which is, I told you, A11. We are assuming x as our first variable. So fxx, fxy, fxz. A11, A12, A13, A21, fyx, A22, A23, A31, A32, A33. So this is the diagonal elements are minus 18, minus 4, minus 108, xy and yx they are same, xz and zx they are same, yz and zy they are same. So the condition is if the principal diagonal elements are of same sign. You can see here the principal diagonals, all three of them are negative. Here f of xx, f of yy and f of zz, they all are negative. So we are going to check the condition of maxima. The condition of maxima is the principal diagonal elements are of alternate sign. Already f of xx is less than 0. Now consider f of xx, f of xy, f of yx, f of yy. Minus 18, minus 6, minus 6, minus 4. 72 minus 36. 36, it is positive. And the third one, that is the determinant of A should be negative. Now consider the determinant. Consider the determinant of A, that is determinant of minus 18 minus 6 minus 18 minus 4 minus 108. This is minus 6 minus 6 18 18 minus 6 minus 6 18 18 0 and 0, because basically it is a symmetric matrix, right? So now we can expand it through the third row. If I expand, then this is 18 times this into this minus this 0 plus 72, then minus plus 108 times 72 minus 36. 72 minus 36. Okay, so this is equal to, so 18 7 126 and 18 to 36. So its value is 1296, and obviously this is plus 18 into 36. 18 into 36. 18 3 ka 54 and 18 6 ka 108. So this is 648 and 1296. Wait, should be negative now. This is minus curly x curly z. Okay, this is minus 108. This is minus 108. So it is 3600, and if we multiply it with 8, 8 3 ka 24 plus 4 288, 88. So its value is 1296 minus 3888. Definitely this is less than 0. So we get here f of xx is less than 0, f of x, f of xy, f of yx, f of yy is greater than 0, and determinant of is less than 0. It means that the point 0, 0, 0 is the point of relative maxima. Point of relative maximum. Okay, so basically this is the condition of maxima. What is the condition? If all the principal diagonal elements are negative and the principal minors are of alternate sign, negative, positive and negative, then this is a condition of maxima. Condition of minima means the principal diagonal element should be positive, means they should be of same sign, and if principal minors are also positive, then this is the condition of minima. Okay. Okay, now let us consider this one. So here also we get one realize because it is a polynomial function. So you can see here only this term depend upon x, y and z. Okay, we know that second order derivative of x with respect to x is constant, and these two derivatives would be zero with respect to x, with respect to y, or with respect to z. So it clearly shows that second order derivatives are negative only. So it means that we need to check the condition of maxima. And if all of them are positive, that will give us the condition of minima. And if they are of not same sign, then it is a condition of neither maxima nor minima. Right? Like here in this case, it is a polynomial function, x square, y square, but these two are positive, this is negative. So it means that it is a condition of neither maxima nor minima. Let us try to check. So what is curly f upon curly x? 8x, 12y. This is 8x plus 12y. If we calculate curly f upon curly y, then this is 8y plus 12x minus 6. 8y plus 12x minus 6. And curly f upon curly z, 0 plus 0 minus 2z, 0 minus 0 plus 1, minus 2z plus 1. Right? So for the extreme point, stationary point, the condition is curly f upon curly x equal to 0, curly f upon curly y equal to 0, and curly f upon curly z equal to 0. So it will give us 8x plus 12y equal to 0. So what is x? Minus 12y by 8. So minus 4 by 3y. Sorry, 3 by 2y. And this is from first equation. From second equation, 8y plus 12x minus 6 equal to 0. So x is minus 3 by 2y. So 2 1 ka to 6 ka. So 8 minus 18 minus 10y minus 6 equal to 0. So the value of y is 6 by 10 minus 3 by 5. So x is equal to minus 3 by 2 to minus 3 by 5. So its value is 9 by 10. And curly f upon curly z equal to 0 means minus of 2z plus 1 equal to 0. So the value of z is 1 by 2. So the point is 9 by 10 minus 3 by 5 and 1 by 2. Now we need to find out second order derivative with respect to x, with respect to y, and with respect to z. So curly square f upon curly x square. This is curly by curly x of 8x plus 12y. 8. Curly square f upon curly y square. Curly by curly y of curly f upon curly y is 8y plus 12x minus 6. So its derivative is 8, again positive. About curly square f upon curly z square. This is curly by curly z of curly f upon curly z. Minus 2z plus 1. Minus 2z plus 1. This is minus 2. Less than 0. So because fxx, fyy and fzz are not of same sign, it means that the point 9 by 10 minus 3 by 5 and 1 by 2 is the point of neither maxima nor minima. Okay. So in case of even three variable, we can easily judge if it is a polynomial function that either the given point is the point of maximum or point of minimum. Okay, so we simply need to focus on the second order derivative. Okay, in case of polynomial function, we can understand this thing that second order derivative with respect to x. This is constant, this is constant, this is constant, and this whole term will be zero. So second order derivative with respect to x is positive because of the positive sign. This is positive, but this is negative. So because they are of not of same sign, so it is a point of neither maxima nor minima. Whereas in the last problem, it is clearly visible that they have a negative sign, means they must give us the point of maxima. Okay. So I hope you will get the concept of relative maxima and minima for the function of two or more variables. Okay. So in the next video, we'll try to consider some problem based on absolute maxima and minima. We just revise the concept, whatever we have discussed so far. Still, if you find out any doubt or any query, then you can post your query to the comment box. I'll try to provide you the solution of the same. Thank you. Have a nice day.